everyone. So last class we learned the distance of the two lines, the distance of two parallel lines. We know when once the parallel line, what parallel line? Parallel line. Let's several different conditions of parallel line, right? So I talked about one of the parallel line is first kinds of parallel line is something like this: x1 equal 1. I give you two examples: x2 equal 5. This line is called vertical line, right? Something like here, x equal 1 is like this here, right? X equal 5 is right here, right? So the distance of these two parallel lines, will be, oh, I thought line. So the distance of these two parallel lines would be, this one is x1 equal 1, this one x2 equal 5. The distance actually, you can see, what we earlier talked about is do a vertical line, a between line, right? So vertical line. Suppose here is y equal 5, vertical line, right? This vertical line. You can see this dot is 1, 5, and this dot is 5, 5, right? So the distance of this one is d equal 4, right? It's come from here. So this line is y equal 5. The distance actually is find the distance of these two dots. So these two dots, since the y is the same, the difference between the x will be the distance, right? So easy to get the distance between these two parallel lines is the 5 minus 1 absolute value, right? So this is the first situation, right? Second situation is, we say two parallel line is two horizontal line. Let me clear. Two horizontal line. Say y1 equal, I give whenever, -5, y2 equals 6. All right. So you can see y1 equal -5 is right here. y2 equals 6 is right here. So the distance between these two lines, actually you do a vertical line, do whatever vertical line, something do vertical line right here, vertical, which is perpendicular to this horizontal line, actually became vertical line, right? So this one will be whatever number, say x number, and y is 6, right? And this dot would be what? Whatever x, right? The other one is -5. So the distance between here is 6 minus 5. So the distance between these two equal 11, right? So these two kinds of parallel line is easy to be got it. So go back to see this kinds of thing. The distance between here, so you can find is 4, right? The distance for this example, second example, will be what? 6 minus negative, 10. Right? And you got 10. Yeah, so this two is easy to understand. Okay, let's see the next one. So the third kind of situation, actually, this is vertical line. All right, this is two parallel line. One is x plus 4. So you can do quickly, do the y interception is right here, x interception right here. So you can do graphing. I'm sorry. You can graphing like this one quickly, right? Extend it. The other one, x plus 8. So one is start here, the other is -8. So you can just do like this. Two parallel line, right? Okay, so how we do this one now? How we find the distance between them? Okay, so we can see here is here is C2. Okay, we can say here is 0, 8, right? Here is 0, 4. All right, so we find the distance, actually find this dot to the vertical line of them, right? So we need to find this dot. We know this dot is 0, 4, and we know this dot is 0, 8, and we don't know this dot yet, right? So actually it's find that the distance between these two parallel lines will be this part. We need to find this. Okay, so we can get from here. So this part is what? This part actually is C2. Is if we say y equal ax plus c, or mx plus c1. This one was mx plus c2, right? So because of their parallel line, so the slope is the same, right? Slope the same. They are the y-intercept is different, right? Okay, so you can get this kinds of triangles. This part is absolute value between C2 minus C1. Here, for this, our example here is 4, right? So here is 4. All right. So what's the special here? What's the special? How to find this D? How to find this triangle? Based on this triangle, find this D. Earlier, what we give the example is say, okay, we find this vertical line, a perpendicular line. So the slope will be what? Because of this slope is 1, right? So this slope will be -1. And -1 pass through here, so pass this dot, so you can get y equal, so this line is this perpendicular line, y equal -x plus 4, right? So this line is y equal -x plus 4, and this line is y equal x plus 8. So we got this dot. We can based on the system. We use build-up system here. So we find the cross point. This cross point would be what? So left minus left equals 0. Left minus right minus right. -2x minus 4, right? Equals 0. So x equal -2, right? So x equal -2. Is it correct? Okay, so x equal -2, y equal what? Y equals 6, right? Right? So this dot we can find out is -2, 6. So we know these two dots, based on the 2 dot distance, we can get what? Got this D, right? Actually it's here. So you can get is the distance, this D equals what? X1 minus X2 is 2, right? Square. Plus Y2 minus Y1, also 2, right? Square and square root. So you get 2 square root 2. 2 square root 2. Right? So here, this number is right here. Actually, you got it. Actually, right now, we try to use the second method. So this is the first method we teach earlier. We find a perpendicular line, find the cross point, and then find the distance of these 2 dots. Okay, all right. So from now on, today I summarize into a new methods. Actually, we talked last week. What do we do here? So let me use the different color line we can do here. So you can see here, we draw these kinds of triangles. Okay, so we know this distance is C2 minus C1 absolute value equal 4. All right, so this is D. All right, go back to see this one right now. You can see here, it's another triangle here. Okay, what's the specialty of these 2 triangles? You can see this triangle and these 2 triangles. What you found out here? What do you find out? You can see actually this part over this part is the M, right? So here is C2, I mean, here is C, right? C, you can see here, whatever is here is 0, C2, 0, C1. Let me clean partially offline, make sure you can see the screen, okay? What are we talking about? Cleaning this one. Just remember our D is here. So I clean this part. So make you guys can better see what I try to talk because I'm too busy of this screen. Okay, so I try to wipe this part. Okay, all right. So you can see the triangle. Let's do triangle here. One triangle is this one. So we know the distance of here is 4, right? And another one is based on here, these triangles. These triangles. We know this slope of this one is 1, right? Because of this slope, x equal x plus 4. So slope is 1, it's from here. So it means this side and this side is the same. This side is the same. And so it means because of this triangle and this triangle is similarity. You can see here these triangles. If you extend it here as well, you can extend it here as well. These big triangles and all these triangles is their similarity, is their similar, right? And you can see these triangles is also similar. So you can see this is angle, this angle, and this angle. If you know geometry, you will learn basic geometry. This angle plus this angle became 90 degrees, right? Because of this is the right triangle. So this angle plus this angle is triangle. It's the same. This angle plus this angle is 90 degrees as well, right? So this one is the same triangle. This triangle, what's the come this from? Is C, and this is, we don't know this what, right? But we know this part. This one over this part. Here, this distance here, we say x is actually here is 4, right? -4. So here also 4. So you can get this part, or this part is what? 4 square root 2. Where square root come from? It's because of 4 square plus 4 square and square root of length, right? So this triangle, it's based on our earliest triangle A, B, C. So if you know A, if you know B, you can get a C, right? We talked this a little bit earlier. So the similarity here. So you know this triangle. So we see this triangle. The angle here plus these triangles, so equal 90 degrees, because of here is 90 degrees, totally 180 degrees degree. So this angle plus this angle is 90 degrees, and this angle plus this angle also 90 degrees. So it means this angle the same this angle. So this angle means what? It means this part over here equal this part over here equal m, right? And this part over here equal m. See, so they have the same, has similarity. So you can see here square root over 2. This part is square. This angle is, I mean, this distance of this one is square 4 square root 2 over 4. So we can build a relationship here. Is this 4 over here, 4, this 4 right here, and this one is the D. Is the same as this part over here. This part over here. So you can see D is equal what? So it's 4 divided square root 2, right? So we rationalize just both top and bottom times square root 2. So the bottom became 2, top became 4 square root 2. Continue simplified, so became 2 square root 2. Okay, so we use the geometry measures here to get a distance. You can see earlier we can use the vertical line, perpendicular line to find the distance between these two parallel lines. We also use a geometry methods to get it here. And actually this one is exactly like this picture I'm show up here. Did you guys see this picture here? As I try to summarize. So let's see this picture right now. See this picture right now. So whatever these kinds of line, whenever we give a linear line, they can be divided into first line is y equal mx plus c1. The second line can change for y equal mx plus c2. So here is c1, here is c2, right? So the distance between here is c1 minus c2 absolute value. Okay, so the distance between here equals what? Let me clean the screen. So we use this, everyone see this kinds of chart, see chart here. So you can see here, just like they are described here, the first dot, here is C1 minus C2. The distance, if you use our methods, whatever we measured here, the distance here is the same distance here, right? Anyone, you can pick anyone. So A1, you can see A1 here is negative C2 over M. And what about this one? It's negative C2 over M 0, right? So this one is negative C1 over M 0. Okay, all right. So you can see this angle here is C2, right? Over this part became M. All right, so D equal what part? Actually, we equal D here, right? We try to find this D. Actually, you find this D, the D. How you got this D? Let me zoom it out. Let me zoom it out a little bit so you guys can see a little bit clear. So objective here, we just try to build a relationship. Objective over here, we try to build a relationship between D and M and C1 and C2. So they told you only M, C1, M, C2. And then we want to find out the D. What's the relationship between them? Right? They told you the slope, they told you the one of the line, y-intercept and another intercept. How you find this distance? That's the objective here, right? So we know this point is 0, C1, and this one is 0, C2. And this part where we told M is the slope. Slope means this part over this part became M, right? And this part over this part became M. So just like say, A, they already told you, here should be C2, right, over M. And this is B. This one is negative C1 over M 0. All right, so we know the A, know the B, so you need to find this D. Only we know that one is, this angle is from this, the distance of here over here is M. So the distance here over here also M, right? This part over this part. We don't know this part. We don't know this part, but we know this part right now since we told you A is here, A is here, B is here. We only know this part over this part became M. Okay, all right. So what do we find out? So we can use the tripod, the methods here. We still give this one distance. We give another distance. We're supposed to give an E, all right? Give a E. So we know E squared. Let's see here, E squared plus D squared equals this part square. This, what's the distance of this one? This one is negative C1M minus negative, right? Square. See, we can see it here. And we also know is D over E equal M. D over E divided E can M. Okay. So what do we got here? So we try to say E. This one we can extend it as E equal D over M, right? Replace this one right here. So replace this part here. So you can D square, right? E replaced by this part, right? Plus D square, right? God, what's this part? This one we do proper changing. This one is minus negative C, so it's became positive. So here we can C2 minus C1 M square. All right. So let's see this one. I'm do change here. So left part became what? D square M plus 1, right? So left part, D square, we take it out. What about the right part? Right part is C2 minus C1 square M square. All right, we do this part, we also do changing. We became like 1, we became what? 1 became here, became M square. All right, so M square actually is cross out, right? Because of both denominator has the same M square. So you can see D square equals what? Equals C1, C2 minus C1 square divided 1 plus M square, right? All right, so D, both sides square root, both sides square root became what? C2 minus C1. So after square root, we give them absolute value, should be positive, right? The bottom part is, that's it. So this is the formula, what we got. So important here, okay? Please remember this one. So whenever they told you M, C1, C2, we can build their relationship here. So absolute, all right? So here plus, all right. So this is the relationship between D with the slope and the 2 y-intercept. So let's check this one right now. Right now we know this 2 distance between them is the D equal to square root 2. Let's use this formula. Can we confirming it or not? All right, in these examples, M is 1, right? M is 1. C1 doesn't matter. You can pick one of them. You can pick 2 or pick this one, doesn't matter. You just need one of them is C4, the other one is 8. All right, let's put this inside if they make sense or not. All right, so D equal C2 and C1. So A minus 4, right? 1 plus M square, M is 1, square root of M. So the top is 4, right? The bottom is square root 2. So you can get 2 square root 2, right? So it's confirm. This formula is very good to confirm. So since we have this formula, we can easily to check these 2 examples. I sent these 2 as an example for your homework. All right, so let's see this two. I print screen this slide first before I clear. Can you guys print screen this one and save it? Because I recorded already here. Okay, print screen and save it. Okay, all right, so if you print screen, I clear the screen. Let's do this two. I make this one a little bit smaller, put the right corner here. Okay. Okay, so go back here. So we just, let me rewrite this one. The D is what? C2 minus C1, absolute value, square root 1 plus m squared. All right, let's see this example now. So this example, the m equal 2, right? Because m is from this here. What about C1? C1 we say 6, C2 is -3. Put this in this formula. So the distance of these two parallel lines, what do we got? So we just, firstly, we put the data in first. Okay. So what's the C2? C2 is -3. C1, 6. What's the slope? What's the slope? Slope is 2, right? 1 plus 2 squared, right? One step. So this is all just replace this data into the letters. So you got a 9 on top, the bottom is square root 5, right? So you can got both top and bottom times square root 5. So you can got a nice, okay, so you got, so that's the result. See, make it more easier, right? More easier. All right, see this example now. This example. So in this example, actually they didn't transform. They don't like this one, right? They don't like this one. They didn't write out already. So what we should do, the first step, we can do some proper changing. Okay, let's do proper changing. So first one, let's see this equation. 5y equal what? -3x plus 8. Both sides divide 5. So y equal -3 over 5 x plus 8 over 5, right? So you can see this one. Let's see second line, second equation. Second equation is 10y equal -6x minus 24, right? You guys can do this transformation. So you can got both sides divide 10, both divide 10. So you still got -3 over 5, right? Because -6 over 10, after simplifying is -3 over 5 x, and here is -24 over 10. So it became -12 over 5, right? All right. After this kinds of transformation, you can see the slope m equal what? M is this part, right? M is this part. They are the same. It means this two line is the parallel line. They definitely should be same. If they are different, they are not parallel to each other, right? So they are this parallel line. So m equal what? M equal -3 over 5, right? What about C1? C1, we pick one of them is 8 over 5. C2 equal -12 over 5. Right? Put this data in this formula again. Right? So D equals C2. C2 is -12 over 5 minus C1. Right? You got it here. So 1 plus m squared. M squared. M is -3 over 5 square root of length. All right. So the top part is 20 over 5. So got a 4, right? The bottom you can get is 5 square. Here is 9 over 25, right? 1 plus together. So here actually is became what? Became 25 over 25, right? So it became 34 square root of length. So actually this part became what? Became 4 over square root 34 over 5. So became 20 square root 34. Actually it's continue changing. So here became 20 square root 34 over 34, right? And it became 10 over 17 square root 34. So this is the answers. This is the answers. Okay. All right. So let's begin its more popular kinds of formula if we met this situation. So actually this one, actually we can find out sometimes the line, they do writing like this way. Let me save this screen again before I raise some part. Okay, so this one actually, if you keep this in your mind, sometimes this one they express like say ax plus by equals c, actually c1, okay, this is c1. You can see this one do proper changing, became 3x plus 5y, both sides divide 2. So you can see the left part is the same, 3x plus 5y equal negative 12, right? So you can, the second line actually is became C2. The left part is exactly the same, the right part is different. So there is parallel line, right? Parallel line. So you know here, you can see these kinds of formula. So what the m equals to? M equals what? M equal negative a over b, right? Negative a over b. That's it. You put a negative a over b. You can transfer b, and actually this situation, just do proper change into this part. You can still use this formula. All right. Okay, so we pay a lot of time to do this part. I want to go back to see. Oh, carry a little bit late. So this is a very important part, very important for our understanding how to do this part, how to find the distance between two lines. Just remember this one first. Okay. Okay. So let's go back to see. Go back to see the 1 point distance, the distance from one dot to one line. Go back to see how to find out the dot distance to one line. Let me do this way. Where I got. All right, let's see this one now. Okay, so let's go back. So we know y equal mx plus c1, y equal mx plus c2. These two parallel lines. So you can find the distance between these two lines based on the formula like this way, right? You can find the distance. If you know the C1, know the C2, know the M, you can find the distance. All right. So this is a two parallel line. So how you find out the dot? Right now, what a long time ago we talked about, say, a dot. Let's suppose that's a dot right side. How you find the distance between these two? The same methods earlier we talked about. First one is we find a their perpendicular line, right? We find a perpendicular line of length first. So if they told you, say, this is the line, initial line is y equal mx plus c1 plus c, okay, just plus c. All right, another dot is here is, we say x1 or y1. So the distance, what do we need to find the distance? We find this dot to a perpendicular line and find their cross point and then find the distance between them, right? That's the logical methods. So since we know the distance between two parallel lines, can use these methods. Got it. We right now introducing a second method to find this distance quickly. How we do this math a little bit quickly? Let's do like this way. All right, let's do like this way. Keep this focus, everyone. Let's do this way. Okay, so I use, firstly, we do a parallel line. A parallel line. So this is the slope here. We do a parallel line right here. Okay, so what is parallel slope? The slope also m, right? So we can say y equal mx plus c2. So initially this one is assigned c1, okay? So since this dot pass this dot, this line pass this dot, so we can put this dot right this formula. It makes sense, right? So it means y1 equal mx1 plus c2. So y1 is told from here, right? x1 is told, m was told, so we know the c2. So we find the c2 equals what? C2 equals what? y1 minus mx1. Got it? So we know the c2 is got it. C1 is got it. We not find the C2. Find the C2. We find the C2. Okay, so we use the same. We know this is the one of the linear line. This second linear line, right? So the distance between these two parallel lines, we transfer the dot to a line into a two parallel line, the distance between them, right? So actually, you can see this line, this blue line, we know y equal mx plus c2, right? C2 is equal this part. So we know the C2, and this one was told already, right? This one was told C1 already. So you know the Cm, you know the C1 and C2. We put this data right this formula. Did you see is the similarity between them? You can see we transfer the dot to one line distance into the distance between two parallel lines, right? So, okay, so this one became further changing what? Changing into D equal, so C2 right now is y1 equal mx. This is C2, C1, all right? The rest is exactly the same. No changing, only C2 replaced by this one now. Okay, so right now it became more easier, right? More easier. Okay, so keep these two in mind. We'll take a 5 minutes break and go back to review the homework. Okay, so actually today we're introducing different methods to find the dot to a linear line. So take a 5 minute break, come back 10:46. So we review the homework part. Sounds good? Sounds good, everyone? Any question? Let's leave
No.
question a little bit later, okay? Just take 5 minutes break.